Okay, so in this video, we are going to do 7.3, question number 9. We're asked to find a sum or a difference. Now, sum is the answer to an addition problem, and a difference is the answer to a subtraction problem. So in this particular case, since it's subtraction, we're going to be finding the difference. The first thing that we want to do is we want to factor each denominator. The reason for this is that that'll help us find the least common denominator, because as we know, when you're subtracting fractions, you need like terms, you need a common denominator. So step 1, factor each denominator. And if it's helpful to compartmentalize your thinking, we can do this kind of as scratch. And I think that's what I'm going to do. I'm just going to go ahead and factor green. A squared plus 6a plus 8. My leading coefficient is a 1, so I know this much of my story. I'm looking for two things that multiply together to give me 8 and add up to 6. That's 4 and 2. So here we have it, green is green. Now the other denominator, a squared plus 12a plus 32, again my leading coefficient is 1, so I know this much of my story. And I'm looking for two things that multiply together to give me 32 and add up to 12, and that's 4 and 8. All right, so now blue is blue. So now I want to find my least common denominator. Right? And if I look at the green denominator, it has an x plus 4 factor. And so does the blue denominator. I don't need to double count this. So I just need one. I apologize, I said x instead of a. I just need one a plus 4 factor. Now, the green denominator also has an a plus 2 that the blue denominator doesn't. So I'm going to need an a plus 2 factor. And the blue denominator has an a plus 8 factor that the green doesn't, so I'm going to need that a plus 8. Okay. So that's our LCD. That is the smart denominator, common denominator that we want. All right, so now that we know the denominator that we want, we're going to go ahead and get that common denominator by cleverly multiplying by 1. So step 3, express each fraction with this common denominator. And we do that. I apologize. I apologize for the dog barking, and we've had so many disturbances. I'm going to just keep going on with this video. So what we have so far is we have 2a plus 3 all over the green denominator. And I'm going to write that green denominator in factored form. Let's just grab it. Minus a plus 14 all over the blue denominator. And I'm going to write the blue denominator in factored form. All right, and you can, with a lot of practice, you probably won't write all this scratch work out. You'll just go from right here and factor each denominator. Okay, so when I look at this denominator, it's missing the blue 8 plus 8 factor. And when I look at this denominator, it's missing the green a plus 2 factor. So that gives me some insight into the versions of 1 that we want to multiply each fraction by. I'll zoom in right here. So we're going to multiply the first fraction by 1 in the form of a plus 8 all over itself. And the second fraction, we're going to multiply by 1 in the form of a plus 2 all over itself. I'm going to go ahead and multiply my fractions straight across. So we have 2a plus 3 times a plus 8 all over that common denominator. A plus 4 times a plus 2 times a plus 8 minus, multiplying numerators, a plus 14 times a plus 2 all over that common denominator. Multiply fractions straight across. A plus 4 times a plus 8 times a plus 2. Now remember, we did this for a reason. We wanted the denominators to be the same. Don't accidentally go backwards and get excited and see a secret times 1 there. We know there's 1 because we introduced it on purpose because we want a common denominator. Okay? I'm going to leave my denominator factored, but I'm going to go ahead and multiply out my numerators. The reason for this is because I'm going to subtract numerators, and there's going to be some like terms to combine. At the very end, we want our numerator and our denominators factored completely to see if there's any secret times 1s. So that's why I'm going to leave that denominator factored. Okay, multiplying out my numerators. 2a times a is 2a squared. 2a times 8 is going to be plus a 16a. 3 times a is plus 3a. And 3 times 8 is 24. And I'm going to write it all over that common denominator. Leaving that denominator factored. Minus, now I'm going to multiply out these numerators. A times a is a squared. A times 2 is 2a. 14 times a is 14a. And 14 times 2 is 28. Order doesn't matter in multiplication. Red times blue times green is the same as red times green times blue. I'm going to go ahead and write it in this order just to emphasize that we have that common denominator. All right, and now it's time for me to subtract my fractions. What am I going to do? I'm going to say this numerator minus this numerator all over my common denominator. And I'm just now noticing that we do have some like terms here. Let's go ahead and combine them, and then we'll do our subtraction. 2a squared plus 16a plus 3a is plus a 19a. All over my common denominator. Minus a squared plus 2a plus 14a is plus 16a. All over my common denominator. Okay. And so once I have this, all I'm going to do is subtract my numerators. Now what's really important is that this numerator has 3 terms. So I need to subtract each of them. In other words, I'm going to distribute the negative. The sign is going to change on every single one of these. And if you wanted, you could even say, hey, that a squared, by the way, is positive. Okay, so subtracting numerators, we're going to have 2a squared plus 19a plus 24 minus a squared minus 16a minus 28, all over my common denominator. See how we changed a real common mistake is to just change the sign of that first term and not the rest of the terms. Okay, so now all that's left is for me to combine like terms and then look for any secret times ones. Let's do that with some new color. Okay, so with my a squareds, I've got 2a squared minus 1a squared is just going to be a squared. With my a's, I've got 19a minus 16a, which is minus 3a. And then with my numbers, I've got 24 minus 28, which is a minus 4. All over that common denominator. And you can see now that we've subtracted the fractions, the real benefit of leaving this denominator factored. Now that I just have one fraction, I want to look for any secret times ones. Let's go ahead and factor the numerator. I'm looking for 2 things that multiply together that give me minus 4 and add up to minus 3. A times a is a squared. A times minus 1 is minus 1a. Plus a 4a is minus 3a. And 4 times minus 1 is minus 4. So we've factored that numerator successfully. And now I can see that there is a secret times 1 right here in the form of a plus 4 all over itself. So we're done with our final answer, a minus 1 all over a plus 2 times a plus 8. And it's good to go ahead and leave that denominator factored because it helps the reader see that there are no more secret times ones. If you multiplied this out, you wouldn't be wrong. and the computer will accept that answer as well. Let's go ahead and type in our answer and see if we're right. So coming into my answer field, I'm going to click on that little yellow arrow to get my fraction bar. Up in the numerator, I want an a minus 1. And in my denominator, I want a plus 2 times a plus 8. Oops, and I'm not typing it beautifully. A plus 2, a plus 8. I did it again. There we go. I'm going to hit save. It can read it and it looks the way I want it to. I'm going to go ahead and hit submit. And we've done beautifully. Okay, and just for the heck of it, for future classes, notice that this a plus 4 factor, once we removed it, it's not obvious to the reader that a can't be minus 4. If a was minus 4 here, we'd have a minus 4 plus 4, which is 0. 0 times anything is 0. I'd have a 0 in the denominator. So for future classes, you'll go ahead and say, note, a can't be minus 4, because that's not clear when I'm just looking at the answer. Excellent.